today we're going to continue from the feedback theory, right? Clearly, since some of us already work, if you work in controls currently, you kind of already know that the feedback systems are mostly what people care about, right? You care about a disturbance affecting your system, and then you find a way to control it, and then you feed back to your input so that it kind of adjusts the error, so that you go back to what your set point should be. Okay, so page 132 talks about the feedback theory, and I think that once we cover a little bit of this, we're going to go to that page and review some concepts there that I think we need going forward. Okay, so in a feedback system, the output signal is returned as input in a feedback loop, right? So this is the output, and then you return it back. And this is an example of a classic negative feedback control. Now this block is exactly on this page, so they actually have this illustration in the book, in the manual. Okay, so it describes that the numerator will be the product of the transfer functions. The product of the transfer functions in the forward path of the signals is what is your numerator. Okay, so usually given by this term, and then the denominator is something that is affected by if you have a minus sign here or a plus sign here. So they're referring to the sign you have here, actually, the one at the bottom. It could be negative, as in this case, and it could be positive. And when it's negative here, that's when you're usually going to have a plus sign here. Okay? When it is positive, then you're going to have a negative sign here. But you see that most of the conventions that you see in the books, they actually have this convention where it's a negative sign here, and then you have a plus sign at the base. So if they give you a loop like this, okay, what this means is that the transfer function that will represent this particular process will be based on the fact that you have two signals, right? You have one signal coming in as the regular input, and then you have another signal coming in as a disturbance, right? So that means your transfer function should definitely depend on these two inputs in quotes, right? Because these two are the two things that will affect the final output. So that's why you can see here that you write the expression for the output being equal to, for standard closed loop system, this is what you get for the transfer function. We looked at that yesterday, right? Whenever for instance, the controller or a process and another process are in series, we all know what I mean by series, right? Comes in through here, and then the next output of this one is the input for the other one. That's what you mean by series, right? Whenever you have that setup where you have two of those blocks in series and they represent the mathematical expression for the process, you actually have to multiply them, right? So this is the standard way you're going to have it. It's going to be G1S times G2S, all right? And then divided by 1 plus G1S times G2S times HS. Previously, what we saw was what? G1P or GP1S plus 1 plus GP1S times HS. But this multiplication you see over here is because you have things in series. So these are kind of like introduction to the rules in block diagrams, right? So you consider the fact that this whole loop you have over here, let me show you. This whole loop that you see over here, right? This whole loop you see here has to do with an input and it's coming to an output, right? So basically G1S, G2S, and then HS is what you're going to consider with the input to form the output function, all right? But then now you're going to still come in there and say, okay, well, we have another disturbance, but that disturbance has nothing to do with G1 per se, right? So the only block you have here, because of this LS disturbance input, is going to be based on a new loop, right? And that new loop is going to be a function of the numerator, is going to be a function of only what it fits into, which is the G2S, right? Which is this one, right? That's why you have this one here. Okay, and then of course, because you have a control loop, a feedback loop, you're going to consider the whole block, right? Again, you're going to consider the whole block for your denominator, because this is what's going to affect your stability. So this is kind of how, when you have multiple inputs, I think someone asked me this question yesterday, when you have multiple feedback, this is a single feedback loop, but when you have multiple inputs, this is how you can construct your YS function, right? Which is your output function in terms of the different inputs. So if we had another input that maybe came from somewhere else here, or something, that will now be another plus. Depending on how that setup is, you're now going to figure out what you're going to have on the numerator and what you're going to have on the denominator. Okay, so just remember, when you have things in series like this, you have to, the effect of the numerator is going to be that you have to multiply them together. All right, that's why you have this here. Okay, and when you have things where it's just an input disturbance that affecting just one of them, that's the thing you're only going to see in the numerator, just as in this case, right? All right, and then the denominator is always going to be a function of the feedback loop system. If you have more input, you keep adding and then multiplying by the input. Originally the transfer function would have been just ys divided by rs equals to all of these, right? But when you have multiple inputs, you have to consider this contribution and this contribution as affecting your output.